So what we are going to do now is problem 33 from chapter 5 of Halliday, Halliday 9th edition. Okay, so what is this problem 33? We have an elevator and with things inside. So the whole combination, this whole elevator with whatever it's inside, this whole thing here has a mass that is 1600 kilograms. Okay, and well, there are some cable here holding this elevator. We want to know what is the tension force. So let's put the forces that we have on this elevator. Now, the elevator together with its load. So here along the cable, we have the tension force holding it. Well, and as always, we have the gravitational force, mg. Okay, so let me indicate that the things are vectors, and there we are. And these are the only two forces that we have in this problem. Now, what they tell us is that this elevator is initially moving down. Okay, so it starts here moving down. It has a certain initial velocity pointing down, and the magnitude of this initial velocity, let's call it V naught. So the magnitude of this initial velocity is 12 meters per second. Okay, it's going down and then moves a certain distance and then finally stops. Okay, so when it's reached this position here, the V here becomes 0, it stops. Well, the forces are still the same. We still have here the tension and the gravitational force, the weight of the elevator. Very well. The question then of the problem, as we said, is what is this Ft? What is this tension force? They also tell us that this elevator moved by a certain amount. So this displacement is going down. So I'm going to mark this displacement here is going down. This delta x, the displacement is pointing down. And what is this magnitude of this displacement is 42 meters. All right, that's all that is given to us. Now comes, how are we going to solve this problem? To solve this problem, as always, we have to choose a frame. I'm going to start selecting as frame, a frame that is pointing up. Okay, so my frame, the y-axis of my frame is this line here, indicating that any vector pointing up will have positive sign. Any vector pointing down will have a negative sign. All right, how do we solve this problem? Newton's second law. Sum of all the forces equals to ma. We only have forces in the y direction, so what we do here is sum of all the forces in the y is equal to m and the acceleration in this y direction. Okay, following our frame, which force is positive? Well, tension is pointing up. My frame is pointing up. So here I have plus tension force because it's pointing up. What is pointing down? The gravitational force, the weight. So here I have minus mg. So I already took now into account the directions by putting plus, by putting minus. Okay, this is on the left side. What do we have on the right side? On the right side, we have the mass of this object and then the acceleration. Let's think a little bit. What is the direction of the acceleration? We start with a certain speed pointing down, and this velocity is pointing down, and then we stop. The elevator is going down with a certain initial speed, and then it stops. That means that the acceleration is opposite, correct? So the acceleration is opposite to the direction of the velocity. Okay? So according to our frame, then acceleration is pointing up, frame is also pointing up. That means our acceleration is positive. I'm going to put plus a here. All right, and now it's just a matter of solving this problem. What we want is to find this tension force. So this is going to be mg. Everything here is now numbers because we already took into account the sign. So m is a number and g is a number. No pluses, no minus. We already took the direction into account. And what we have also plus MA. Okay, so the tension force is M and then magnitude of G plus magnitude of A. We have everything except the value of this acceleration. So we need to find the magnitude of this acceleration to finish this problem. Okay, so how do we find this magnitude of the acceleration? We have all the information to get that. The equation that we can use is this one, V squared equals to V naught squared plus 2A delta X. This is the equation. Now let's put the signs and the numbers here. The final velocity, we stop, so it's 0. The initial is that V naught, which is 12. So here we have 12 squared. Now, you're going to say, should I put plus or should I put minus? Well, according to the frame, is minus, but this minus doesn't bother us much because this is squared. Okay, fine. How about what comes next? Well, number 2, then the acceleration. As we said, the acceleration is pointing up. Our frame is also pointing up. This is plus. Now, careful. How about delta X? How about the direction of the displacement? The direction of the displacement is here, is going down, while our frame is pointing up. So here we have to put minus. And minus what? The displacement, which is 42. Okay, so with that, we can now find what this acceleration is. So if you solve this equation, what will you have to find? You have to find that. How you're going to do that? Now you have 2 multiplied by A minus 42, right? Equals to minus 12 squared is 144. When we put to the other side, it's minus 144. So now the minus sign cancels because it's in both sides, and you can find this acceleration. I think this acceleration is something like 1.71 meters per second. Okay, so we found the acceleration, the magnitude. So let's repeat this. We found the magnitude, and then we can now put this magnitude here. So here we have 9.8, just the magnitude because the sign was already to take into account. And then for the acceleration, 1.71 because the magnitude was, the sign was already taken into account. So it's just the magnitude. And for the mass is 1600. And that's it. We got the problem. Okay, so we'll get the number. The number will be for this tension force, 1.8, 10 to the 4th newtons.